Okay, now we're on our next section for linear best fit models. So take a look at the essential question with me. Oops. How can you use a trend line to make a prediction from a scatter plot? A cluster is a set of closely grouped data. Data may cluster around a point or along a line. Okay, so we're looking at two different things here. We're going to talk about the line of best fit, which you saw a little bit of prior to this, and then we're going to be talking about clusters as well. So let's look at example 1 together. A scientist gathers information about the eruptions of Old Faithful, a geyser in Yellowstone National Park. She uses the data to create a scatter plot. The data shows the length of time between eruptions, which is the interval, and how long the eruption lasts, which is the duration. So our interval in minutes is our x value, and our duration in minutes is our y value. Okay, so again, the interval is between eruptions, and the duration is how long that eruption lasts. Okay, so if we take a look at, oops. Let me get my pen up here. Sorry, guys. Okay, so if we look here at this point right here, this is saying that 40 minutes in between, the eruption lasted about almost 2 minutes. Over here, when there were about 55 minutes in between, the eruption lasted about 3.5 minutes. Okay, so again, when the interval is between two eruptions, this doesn't necessarily go in order. Okay, so they're just saying when there were 40 minutes in between eruptions, the eruption only lasted just under 2 minutes. Up here, when there were 90 minutes in between eruptions, you're looking at about 4.5 minutes. Okay, so that's how to read this graph. A, describe any clusters you see in the plot. So this would be considered a cluster. This would be considered a cluster. Okay, so those two would be considered clusters. Describe what's happening. So all you would write would be something like between 40 and 60-minute intervals, you have a cluster of the duration lasts between 1.5 and 2.5 minutes. When the intervals are 70 to 90 minutes in between, you end up with eruptions of 3.5 to 5 minutes. So that would be like a description. So you decide in your own words how you would put that. Next is, what do the clusters tell you about the eruptions? So that's up to you. And a little bit of what I said for A could follow into B. You wouldn't have the same exact answer, but they are definitely related. C says, describe any outliers you see. This little guy right here is an outlier. When it says describe, we're asking what's happening there. So we've got a little guy here when there were 55 minutes in between. It was a 3-minute eruption. Now let's take a look at what that means for a second. If I look at 55 minutes, okay, do you see how right down here, I have a few eruptions that are around 55 minutes and they only lasted under 2 minutes. This guy was a 55-minute in-betweener and he lasted more than 3 minutes. So it's an outlier because any other time there was 55-ish minutes in between, the eruption was much, much shorter. So that's an outlier because it doesn't follow the pattern of the other 55-minute interval eruptions. Okay. Reflection, 1A. You're going to answer 1A and 1B on your own, but okay, let's take a look at example 2. The scatter plot shows the relationship between the number of chapters and the total number of pages for several books. So here's our chapters, here's our pages. Draw a trend line, write an equation for the trend line, and describe the meanings of the slope and y-intercept. So there's a lot to do. We're going to walk through each step of this together. So let's focus on A first. Draw a trend line. It will be easier to write an equation for the line if it goes through 2 data points. Hint, use 550 as one of the points. identify another point that the trend line goes through. So as of right now, they want us to use this point right here for our trend line. Now, a couple things about the line. We are not trying to connect every dot. If you connect every dot, you've now created a line plot, and that's not what we're doing. We're making a scatter plot. The other thing they tell you is to write an equation. It's easier if you have the line go through 2 points. That's because if we have 2 points, we can find a slope. There's a lot of assistance that you'll have along the way if you've got 2 points that it goes through. The only thing is you need to be smart about the 2 points. If I were to draw this line, it does go through 2 points. You'll notice it goes through a point right here and a point right here. However, that's not really a best option for us. So let's clear that one out. It needs to go through 550. So at this point, if I drew a line right here, it does go through 2 points. It goes through 550, and it goes through this one right here. The only issue with that is if I look below my trend line, I've got 1, 2, 3 points, but above I've got 1, 2, 3, 4, 5 points. So that's not going to work either. I want this line to go through 2 points, but it also needs to have just about as equal as possible when it comes to the amount of points above and below. So if I take a look at this line, it goes through 550 like it hinted for us. And it also goes through this point right here. And if you count above and below, I've got about 4 above and I've got 4 below. So it's pretty even here. And this follows the trend line pretty well. And if I look at the point that I made red over here, it's at 17,170. Okay, so definitely use those 2 points so that we can work through this together. Now B asks, what type of association does the scatter plot show? So from left to right on this plot are the points that are scattered in an increasing association? Is there a decreasing association? Remember, if my line is going up from left to right, that's increasing. If I'm going down from left to right, that's decreasing. If it's kind of straight across, it's no association. So decide what kind of an association is happening. Now when we look at C, do you expect the slope to be positive or negative? Now the trend and the slope actually tell the same thing. If you reach back into your memory with slope, if my line went up from left to right, it was a positive slope. If my line went down, it was a negative slope. So you'll notice that B and C are actually go hand in hand. If our association is increasing, my slope will be positive. If my association is decreasing, my slope will be negative. So you go ahead and answer those 2 questions. Okay, and then let's look at number 4. Look at D and E. So D and E is where we're going to take our point 1770 and the point 17,170 and the point 550, and we're going to start working with those 2 points here. So D, find the slope of the trend line. So what we're looking at here is, again, reaching back into your memory. If I have 2 points, the slope is y2 minus y1 over x2 minus x1. That's how we find the slope if we have 2 points. I find how the y changes and how the x changes, or rise over run. So they already included the 5 and the 50. So I have my y's that I'm going to subtract. So it's 170 minus 50, and it's 17 minus 5. So I end up with a 120 over 12, and that simplifies to 10. So my slope is 10. Now look at E. Now, side note, if your slope turns out kind of crazy, like a fraction, it's not a bad thing. However, I would revisit your scatter plot and see if it's possible to find a point that still creates a good trend line, but that will give you a nice slope to work with. So let's take a look at E. E says use the equation y equals mx plus b, the slope, and the point 550. Substitute values for y, m, and x into the equation. So we have a y and x with our 5 and 50. And now we have an m, which is 10. So we're going to use our x of 5, our y of 50, and our m of 10. Now I could use the 170 and 17, but we were given the 5 and 50, so we're just going to go ahead and use that. So y is 50, m is 10, x is 5. We do not know the b. So now we're going to simplify, and we get 5 times 10 is 50. Now what we're doing, I don't know if they're having us write this again. Now it says subtract the number that is added to b from both sides. So I'm going to subtract 50 from both sides. I get 0 plus b equals 0. So b equals 0. Use your slope and the y-intercept to create an equation. My slope was 10. My y-intercept is 0. Y equals 10x. I'm going to clear it off, so pause and copy anything down you need copied. So F and G. F says, what is the meaning of the slope? Okay, so let's take a look at our slope and look at our graph for a second. Okay, so for our line, oops, sorry. Let me deselect here, oops. So for my line, this is what my line looked like. And a couple things, my slope was 10, or 10 over 1. My y-intercept was 0. Okay, so my y-intercept is 0. Let's take a look at what that means. If I look at the numbers, if I have 0 chapters, how many pages will I have? 0, right? So this is saying 0 chapters equals 0 pages. That makes complete sense, right? Yeah, totally does. Look at my slope for a second. Slope is a rise over run, or a change in y over change in x. My y is pages, so it's the change in the pages over the change in the chapters. 10 is pages, 1 is chapters. So what this is saying is for every 1 chapter, I should have 10 pages. On average. It won't be the same every single time, but about every chapter should give me 10 more pages. Let's take a look for a second. So if this follows true, at 2 chapters I should have about 20 pages, and I'm pretty darn close. 4 chapters should be about 40 pages. 6 chapters is somewhere around 60 pages. I'm pretty close. This is a give or a take, okay? 8 chapters, I have about 80 pages. In this case, I had a little bit more on one point and a little less at another point. But in general, I can count on 1 chapter being about 10 pages long. That's all that's happening here, okay? So let's go back to your question and let's answer it. What is the meaning of the slope in this situation? So in your own words, remember our slope was 10 over 1. 10 pages for 1 chapter. So it's how the pages change compared to how the chapters change. G, what is the meaning of the y-intercept in this situation? Our y-intercept was at 0, 0, which meant 0 chapters and pages. So at 0 chapters, I would have 0 pages. Now, I wrote this in math. You're going to put this into words. Hit pause if you need to get that finished. Now let's take a look at 3. When you use a trend line or its equation to predict a value between data points that you already know, it's called you interpolate the predicted value. When you make a prediction outside of the data that you know, it's called you extrapolate the predicted value. Okay, so this is telling you sometimes you know the data and you make a prediction about it, and that's the interpolate, like interpret. Outside is extrapolate. That means you don't have data for this right now, but you're going to use the information to make a prediction. Okay, let's take a look at this happening. So refer to the Scatterplot trend line in number 2. Use the equation of the trend line to predict how many pages would be in a book with 26 chapters. Is this prediction an interpolation or an extrapolation? So we want to predict how many pages would be in a book with 26 chapters. So let's take a look back up here. I'll draw the line again. Okay, so here's what we want to know. If you take a look and you were to extend this line here, okay, let me extend my line. So let's say I were to extend this. And I said we're looking at 22, 24, 26. So if I were to look up here at 26, according to this line, I'd be right about here. So if I were to extend this line, this would be 260, 280, okay? So according to my line, what could I predict at 26 just by looking at this line, not using an equation or any math like that, just kind of visually? I would guess it's probably about, for 26, maybe about 260, 265, maybe, something like that. So without doing any math, just taking a look at it, I would say, according to this, so looking at A, how many pages would it be in a 26? So use the equation of the trend line. I guess we're using the equation now. Sorry about that. So if my equation was y equals 10x, where x is the chapters, y equals pages. So with 26 chapters, I would have y equals 10 times 26, so 260. So it should be about 260 pages. Is this a prediction of interpolation or extrapolation? If you look at what I just did, where I had to extend it out and add parts to my coordinate plane, the minute you have to go outside of the data that's given and try to make a prediction and extend your graph, that's extrapolation. So it would be extrapolation because I had to go beyond the graph. So because I went beyond the graph, that would be extrapolation. Okay. So write an equation for your trend line. Y equals 10x. Substitute the number of chapters with 26. Simplify to 260. I predict the book would have 26 chapters, would have 260 pages. I already did the work up above. Now we're doing it below. Use the equation of the trend line to predict how many pages would be in a book with 14 chapters. Okay, I'm going to clear it out. Hit pause if you need to. Okay, so let's work with the book this time. Use the equation of the trend line to predict how many pages would be in a book with 14 chapters. Is the prediction an interpolation or an extrapolation? So if we look up at our graph, 14 chapters. Oops. Do you see how 14 chapters, if you look at our graph up above, do you see how 14 chapters is actually within my data? So 14 chapters is going to be in this area somewhere. So that would be considered interpolation. Sorry, I know I'm scrolling a lot here. So it would be considered interpolation because you write this in your own words, but we're within the data points. So because we're within those data points, 14 chapters is within the graph, then we know that it's an interpolation. So write our equation, y equals 10x, substitute the number of chapters, and simplify. So I predict the book will have 140 pages. Okay, let's take a look at the next part. We're going to reflect now. How well do your new points fit the original data? Here's what they're telling you to do. if my new points, what they're saying is when I had 26 chapters, it was 260 pages. And when I had 14 chapters, it's 140 pages. This is based on the equation. So what they're saying is if these are your data points based on the equation, go look at your data. Does this pretty much fit with the data? Okay, let's take a look. So if I pull this up and go look back at my graph, I had 14 chapters were 140 pages, and 26 chapters was 260, so we're right about up here. So if I add those 2 points, does it pretty much fit with the pattern? Yes or no? If you think it does, then you say yes and you explain why. If you don't think it does, you say no and you explain why. Okay, so let me go back down here. So that's 3A. You decide when you plot those points, do they fit? So plot the points. Do they fit? Yes or no? Do you think extrapolation or interpolation is more accurate? Explain. So is it more accurate to make a prediction outside of the data or within the data? That's completely your opinion. Explain why. And that's it.